All right, I wanted to give you a little bit of help on how to study for showing that a repeating decimal is a rational number according to the definition, which says that a number is rational if you can find two integers whose ratio is equal to that number. Okay, so there's not a lot of problems in the book, but that's all right. You could just make up your own problems and you can easily check them with the calculator. So, for instance, let's say I want to just like practice doing two digits that repeat. I just pull some random thing out of my drawer, and I'll just pick these first two numbers, 7, 2. All right, I'm going to do what is 0.72 repeating. Okay. All right, so remember the way that we did this is we just set up some variable x equal to 0.72. Okay. And then our goal is to take the decimal point and move it past the chunk that repeats. Okay, so if I move this two places, which is multiplying by 100, I can move it past that part that repeats. So I'm going to multiply both sides by 100. So 100x equals 72.72 repeating. Okay. And now I have these two numbers with a 0.72 repeating. If I subtract them, the repeating part will go away. Okay, so I'm going to subtract the bottom equation minus the top equation. So here on the left side I'll get 99x, and on the bottom I'll get 72. And so that means x is 72 over 99. Or if you wanted to reduce that, I guess 9 goes into there 8 times and 11 times. So you could write 0.72 repeating as the ratio of 8 over 11. Okay, so we could always check it to see if we're right. 8 divided by 11, not 8 divided by 1, and we do get 0.727272. The only reason we're seeing a 3 there is because there was another 27 and it got rounded, right? But we know it is a 72 repeating. Okay, so let's say we don't have all the digits repeat. All right, I'll go with the next one. So let's do like 5, 1, 2, but we're only going to have the 1 and 2 repeat like that. Okay. So in this case, once again, we would have x equal to 0.512. Now this time, okay, we want to get it in kind of this format where we have the decimal right in front of the part that repeats. So before we move it, we're not going to immediately move it past the repeating part. We're first going to move it in front of the repeating part. So multiply both sides by 10, and this will turn into 5.12 repeating. Okay. After we do that, then we can move it past this repeating chunk, so multiply it by 100. So if we multiply this side by 100, we'll get 1000x, and if we multiply this by 100, we get 512.12 repeating. Okay. And now these two have the 0.12 repeating, and when we subtract them, the repeating parts will go away. So when we subtract bottom minus top, we get 990x, and then here we get 507. So our x is 507 over 990. Okay, and I suppose we could reduce that. They're both divisible by 3, it looks like. So 507 divided by 3 is 169, and 990 divided by 3 is 330. Okay, so if we checked 169 divided by 330, we get 5121212121212, just like we were expecting. Okay, and let's do one with a whole number in front of it. Okay, so let's do here, let me pick something else out of my desk that has some numbers on it. We just need some random, oh look, alright, Frontiers in Education 2018. So let's do 2.018 repeating. We'll repeat 3 this time. Alright, see, you can just use random objects in your desk to make up your own problems. Okay, so think of this as being 2 plus 0.018 repeating. Okay, So we know how to do something like this, and then we'll just add on the 2 after we're done getting this part written as a fraction. Okay, so we're going to have our x be 0.018 repeating. So I've got 3 digits repeating this time, so I'll move it past those 3 by multiplying by 1,000. Okay, and that will give me 18.018 repeating. And so if I subtract those 2, I'm going to get 999x equals 18. And so x is 18 over 999. All right, I guess that reduces 9 goes into there twice, and 9 goes into there 111 times. Always good to check it and make sure. And indeed it is 018, 018, 018. Okay. Now that's just this part of it, so we'd have to add the 2 on. So 2 plus that 2 111ths. So that's going to be 222 111ths plus 2 111ths, giving us a total of 224 111ths. And so we could check that just to be sure. 224 divided by 111. And indeed it is 2.018, 018, 018, and on it goes. Okay. So it's easy to make up your own problems and check them. You know, you can just pick random numbers. Try, you know, having 1-digit repeats or 2-digit repeats. Try somewhere, you know, not all of the digits repeats. Just practice so that you can get good at those. All right, hope that's helpful.